Hi guys, Raz here. Today we're looking at psychology and critical values and significance, lesson three. So in lesson two, we looked at the sign test, and hopefully in this video, I'll just get a bit of understanding as to what critical values are and where they come from, so you'll understand what you're doing when you're doing it. So this bit decides everything. You can calculate perfectly, but if you don't interpret it properly, you lose marks. So I'm going to do something a bit mathy in this bit just to explain the concept of critical values. So let's say John. John tosses a coin 8 times and it comes up heads 6 times. He claims the coin is biased towards heads with a significance level of 5%. Test his claim. So can we really say anything is that biased with a sample size of 8? No, exactly. And that's why mathematicians have gone to the effort of creating these statistical tables. So in some instances, maybe it wasn't easy to get a sample of more than 8. So from this statistical table, this is for a random experiment where you have eight outcomes. We can see that the probability of getting 2 is 0.1445. So if we times that by 100, we will get a percentage. And the percentage before it was 3.52%. Yeah. So what this is saying is there's a 14.45% chance of two heads, sorry, two tails coming up when we toss the coin 8 times. We've been asked to test this at a 5% significance level. So that means that was likely. Yeah, it wasn't abnormal enough for us to say this coin is unfair. Had it have only come up tails once or 0 times, that would have been less than 5%. Therefore, we could have rejected the claim that the coin was fair, and then we could have agreed with John and said, yeah, this coin does seem biased. So the critical value given to us there would have been 1. So anything that was 1 or less would have meant the coin was biased. But our value was bigger than the critical value. Hence, there was insufficient evidence to reject the null hypothesis of the coin being fair. So therefore, the result of 2 out of 6 is not significant enough for us to reject the null hypothesis that the coin was fair. So in your psychology, you'll be given the critical value and you just have to evaluate against it. So in this case, the critical value was 1 or less. So let's talk about some things that you might see. How do we know this is real? I've missed out a bit there. All right. Vaccine reduces infection rates. How do we know this is real and not luck? So, yeah, we need to just understand a few things that notations that you're given. So typically in psychology, you are given a 5% significance. So you evaluate everything to 5%. Yeah. So for example, in that previous question with John, if we'd been evaluating to a 20% significance, well, then we could have said that the dice was, I keep saying dice, the coin was biased. Because we're doing it at 5%, we're trying to strengthen the argument a bit. We're trying to minimize error, and therefore there was insufficient evidence. So for psychology, we use a 5% significance level. One-tailed versus two-tailed. So that depends on how specific the statement is. So the vaccine reduces infection. That is one tail because it's saying clearly we're trying to reduce infection. If it had said the vaccine affects infection rates, that doesn't say whether it's affecting it for the better or the worse. So it's two-tailed. Yeah. So I don't know if I'm getting too mathsy here, but if that's the population as a whole, when we say the vaccine reduces infection rates, we're talking about one side of the population. If we talked about the vaccine affecting infection rates, it could have been this side or this side. We could have been reducing or increasing, yeah, because we're just saying, is it affecting it, whether for the better or for the worse? So that's the difference between one-tailed and two-tailed. And yeah, it's key that for psychology we use 5% significance values. So essentially, critical values is the pass mark for significance. So rule of thumb for most tests calculated. So for chi-squared, whatever you find has to be greater than the critical value for it to be significant. Yeah, significant means you can accept your alternate hypothesis, what you're trying to state, which is against the norm. For rank-based tests, what you calculate has to be less than the critical value to be significant. So that's for a sign test, the Wilcoxon or Mann-Whitney, which we'll go into a bit later. So, but again, you only need to be able to calculate the sign test. So let's apply what we've learned to the example we did in the last video. So we're told the critical value is 2 or less. So our smaller value, which ends up being our S, is 2. So since S is less than or equal to 2, that means the answer is significance. So since S is less than or equal to 2, our value is significant at the 5% level. Therefore, the campaign worked. The campaign worked. It wasn't by chance that they improved. We're saying that we have enough evidence to suggest that the campaign impacted the knowledge of the people watching it. All right. I hope you enjoyed that, and I'll see you again.